So, very similar question here, solving a quadratic inequality. However, the change here is that with our x squared term, we have an x squared with a not being 1. So we do need to change that if we're going to try to factor that. Maybe this is factorable, maybe it's not, but we do need to try because factoring is going to save us some time and save us some steps. So to do that, we'll divide every single term by -1, including the 0. Even though it's not going to change the number, we still do need to divide by -1, which would give us x squared minus x minus 12, and we do need to flip the direction of the sign since we divided by a negative, would be greater than 0. Look to see if we can factor this. Two numbers that both multiply to -12 and also add to -1. -4 and 3 will accomplish that. So x minus 4, x minus 3. And just for the time being, I'm going to switch that to a quadratic equation. So we can get what we need for the sign analysis. Split it off. X minus 4 equals 0. X plus 3 equals 0. And we get that x equals 4 and x equals -3. It's going to flip to the next slide for the sign analysis. Again, it's a number line. We'll put -3 and 4 on it. Both of those values make that function 0. And now we have 3 regions. We need to see what this is going to work out to, positive or negative, in each one. So picking a number on the left of -3, I'm going to pick -4. So we have -4 squared minus -4 minus 12, which would work out to 16 plus 4 minus 12, which works out to 8. So in this left region, any number that we picked there would work out to a positive. Choose a number in the middle between -3 and 4. I'm going to take 0. So we get 0 squared minus 0 minus 12, which works out to -12. That being a negative number, anything in this region would be negative. And choosing a number on the right, I'm going to choose 5. So we get 5 squared minus 5 minus 12, which should be 25 minus 5 minus 12, which is also 8. 8 being a positive number, anything over there would be positives. Going back to the original inequality, we're looking for x squared minus x minus 12 is greater than 0. Numbers greater than 0 would be positives, and there's 2 separate sections, and that's a key thing here. There's 2 separate regions where this is positive. Anything here on the left to less than -3, and anything here to the right greater than 4. So to illustrate that, we need 2 separate inequalities. We need one where x is less than -3, strictly less than, no equal to, because the original inequality did not have one. and a second inequality where x is greater than 4. Again, no equal to line as well. Now, the mathematical symbol to show that it could be either one of these that work as solutions is this symbol. It looks like a U. It's the mathematical symbol for the word or, this or that. And there we go.